In this problem, the uniform rod weighs 420 newtons and has its center of gravity at G, as shown. We are tasked to find the reaction at B and the tension in the cable. We drew our free body diagram for the body, so let's make use of this figure here. So the rod has a weight of 420 newtons acting at the center of gravity. And if we isolate the bar, it would feel a force due to the cable, let's call this tensile force due to the cable T, and then it has a reaction due to the surface of the ground at B that would act perpendicular to the surface. So let's call this reaction B. Now next, since the bar has a slope going from one horizontal to one vertical, so taking the arctangent function of 1:1, that is equal to 45 degrees. So the slope here must also be equal to 45 degrees by the alternate interior angle theorem. And the next, let's solve for the distance going from A to B by making use of the sine function. So sine of 45 degrees, that is equal to the distance of the opposite side, that is 2 meters plus 4 plus 2, that is 8, divided by this distance here, let's call this x. So to solve this x, this is basically equal to 8 over sine of 45 degrees. And what is that value? That is 8 divided by sine of 45, which is equal to 8 squared of 2. Meters. There is a reaction here at A, well, that is acting perpendicular at the surface. Let's call this the normal force RA. Now that we have three unknowns, we can make use of the three equations of equilibrium, summation forces, horizontal, vertical, and taking summation of moment at some certain point. Now knowing this is 45 degrees, by geometry, this angle here must also be equal to 45 degrees. Since by using the alternate interior angle theorem, if this is 45, this one must also be 45. And since this angle here is 90 degrees, to make this straight line total to 180 degrees, we subtract 180 by 45 and 90 to get an angle of 45 degrees over here. So taking summation force horizontal equal to 0, considering rightward force is to be positive, we have the tensile force T minus the horizontal component of the reaction at B. So this R sub B cosine of 45 degrees equal to 0. So we have T equal to R sub B cosine of 45 degrees. And we let this our first equation. Now next, we take summation moment at point A equal to 0, considering counterclockwise to be positive. So we have the tensile force T that would induce a clockwise moment, so it's negative, times the moment arm distance of 2 meters. And then a moment of negative 420 due to its own weight, and since it is acting clockwise, it's negative, times the moment arm distance of this, since this is 4 meters and 2 meters, we can solve for this distance, let's call this y, by making use of the tangent function. So we have tangent 45 degrees equal to the opposite side of 4 plus 2, 6 degrees, divided by the adjacent side of y. So y is equal to 6 over tangent 45, which is equal to 6. So this distance here is just basically equal to 6. So the moment arm distance of 420, that is equal to 6, going from point A. And then next, we have the reaction at B that would induce a counterclockwise moment, so it's positive. So we have RB times the moment arm distance of 8 squared of 2 meters equal to 0. Now we have two equations with two unknowns. We can plug in the value of T from the first equation to the second equation, so that we have a single equation in terms of a single variable. So we have negative RB cosine of 45 degrees times 2 minus 420 times 6 plus R sub B times 8 squared of 2 equal to 0. Now we can solve for the reaction at B. We have negative RB represented as x times cosine of 45 degrees times 2 minus 420 times 6 plus r sub b times a square root of 2 equal to 0. So the value of r sub b, that is equal to 254.56. And it has a unit of newtons. And for the tensile force T, we make use of equation 1. So we have r sub b times cosine of 45 degrees. And the answer is 180 newtons. So we have the final answer for number 1 and number 2. The reaction at B is 254.36, and the tensile force in the cable, that is 180 newtons.